so number one comes from the very first section, because y'all remember what you did the first day of class, right? All right, so we have imaginary numbers. We have them in parentheses so they can separate these two terms from these two terms. Because of the plus sign, we want to combine like terms. We're not multiplying, agreed? All right, so I really don't need these parentheses. I could really just write 13i squared minus 6i plus 7 plus 4i. They just put the parentheses so you can see they're separated by terms, that's all. Now, do we have any like terms here? Yeah, we have negative 6i, positive 4i. So I can leave 13i squared. There's no like term. I combine the two like, it gives me what? Negative 2i. Are signs important in our class? Yes. Because negative $2 in a bank account is different than positive $2, yes? Okay, we gotta know our signs. And then our plus 7. Do I have any other like terms here we can combine? No. Is it written in order? What does order mean? Well, we have an I squared. Can we leave that like that? No. What's I squared? Okay. I squared equals a negative 1. So that means we substitute, because this is 13 times. So that's a parenthesis, or you're doing it in your head, which is fine. Minus 2i plus 7. So we have negative 13 minus 2i plus 7. So we have some additional like terms, yes? All right, so negative 13 and 7 is what? Okay, I'm sorry because I'm running out of space. I wrote too big. Negative 6 minus 2i. Oh, I'm sorry, I'm off my screen. All right. Is that written in the correct order? What's that called? Negative 6 minus 2i. Do we remember that vocabulary? Complex number, good. Okay. Complex number, what class you in? All right, we'll let them know. You got that? Negative 6 minus 2i. So complex numbers written as a plus or minus bi form. So we should write our real part first, our imaginary part second. So, I don't have a blank here. So I'm just going to circle. Here's our final result, okay? There's no x equals, agreed? We don't solve for everything in this course. It depends on what the directions tell us. It said simplify. Simplify is different than solve. Okay. We good? Number 2. Simplify the following expression. Let me bring this up. So we have a denominator here. Do we divide in college algebra? No. What do? Multiply. Okay. So how do we get rid of the 4 plus 5i? Multiply by the conjugate. Okay. So what does the word conjugate mean? The opposite of what part? The imaginary part. So we would multiply, I can't see now, that's 41, right? Yeah, 41. Times 4 minus 5i is my conjugate of 4 plus 5i. And in math, what we do to the top, we do to the bottom. Yes? Okay. So now we're really multiplying versus dividing, yes? Oh, okay. So I'm going to put these in parentheses because we're going to have to multiply. So we got our calculators close by. What is 41 times 4? I heard 3 different numbers. Tell me again. Oh, okay. So that was the same number. I thought I heard 364. Sorry. 164. What's 41 minus 5i? Positive times a negative is a 41 times 5, 205. And we have our I, yes? Divided by or over. Everybody can factor. FOIL. Sorry, not factor. FOIL. All right, 4 times 4. 16. 4 times negative 5. 5i times 4.
20.
It doesn't matter which one you do first as long as we account for each term, okay? 5i times negative 5i. Okay? So we can't just start reducing. We have to combine like terms. The top, we're not going to touch right now. The bottom, what happens in the bottom? Yeah, these like terms cancel, yes? And then we learn from the previous problem 1, we can't leave an I squared. We have to, substitute that negative 1 for the I squared. So in the denominator, we really have 16 plus 25. We can do a little this in our heads, yes? Okay, so what's 16 plus 25? I know some of us are coming in, no worries. We're recording, so try not to walk behind me if that's okay. Grab your pizza, your drinks, whenever you want to get up, just walk the other way. Okay. I'm waiting. 16 plus 25? Oh, did y'all say that and I just didn't hear? I'm sorry. Okay. Can we leave our answer like that? Who says yes? One person? So everybody else says no? You say yes? So you want to separate or you want to ask yourself, can I reduce these fractions? Before you say yes. So what I mean by that is if we separate these into 2 fractions, am I off the screen? Minus 205i divided by 41. Can I pull something out of 41 and 164 that's the same? 4? Okay. So if I pull a 4 out of both, what can I reduce that to? 4 goes into 164 how many times? I'm sorry. Does 41 go into 164 evenly?
Yeah.
Okay, 4 times. Is that what I'm hearing? Okay, gotcha. Can 41 go into 205 evenly? How many times? 5. And we keep our I. So before we say no, we can't reduce, we have to check that. Is that clear? So we end up with 4 minus 5i. Can y'all read my handwriting? I'm sorry. I'm trying to write to the side without blocking the screen. Okay. All right, number 3. We want to speed up a little bit. Is that okay? Oh, y'all like, please. Okay. All right, linear. Now we have the word solve. Questions 1 and 2 were simplified. Solve means we need to, in class, when you solve, you had 3 possibilities. You would get a solution, x equals something. You would get a no solution or infinitely many solutions. So you don't always solve and get an answer. Yes? All right, remember those 3 rules. Okay, well, here we go. If we're trying to get y by itself, get rid of the parentheses. 2 times 5y, 10y. 2 times negative 3 equals negative 11 times 9. Negative 11 times negative y. All right, parentheses gone, yes? All right. The goal is to get... Oh, yeah, I'm just writing too fast and talking. So the goal is to get y by itself, yes? Okay. Y'all can read my scratch out there, 11y? Okay, thank you. All right. So it doesn't matter which side I have the y on. Agreed? I can have solve for y on the right side. It's your personal choice. Just watch your signs. So if we get y by itself, I hope that you've learned or you're reading your book, yes? Y'all all looking down, okay. So we get your book shares with you to move your smaller term to your larger so you can avoid negatives. Because as students, we tend to make more mistakes with negatives. So if you hadn't picked up on that, That's something that can be helpful. So if I move the 10y, it becomes a negative 10y. In math, what we do to one side, we do the other. So now, on this side, I now just have a negative 6 equals a negative 99 plus y. How nice that is, yes? All right. Now we need to get our numbers together. What's another word for numbers? Okay, what's another word for integers? Wouldn't that be a constant also? Yeah, and we've been talking about that in our last chapter 6, right? A lot? All right, so if we move the 99 over, that would be negative 6 plus 99 equals y, which is what? 93 equals y. Is that solved? Okay, so that means we get a solution. Do your teachers emphasize? My students, I like them to write their answers in solution set form with braces. But what works for your faculty, that's your choice. But my students, I want them doing this. Okay. Number 4, solve the following absolute value equations. We had 3 rules we learned about absolute value. What were those 3 rules again? So if the absolute is isolated, it's by itself, it equals a positive, we get how many answers? 2. If the absolute is isolated equals 0, we get how many answers? 1. If the absolute equals a negative, we get how many answers? None. Just like linear equations, we have 3 possibilities with absolute equations as well. Math is rules, guys. If you learn the rules, the math becomes a little easier. But I know we don't want to learn those rules. We just want to do the math. But that's what helps you. All right. I'm going to turn this over. Oh, no. Let me get will you grab me that spiral right there into that graph paper? Because I think other than 2 people in the room, there were some people like, what is she talking about? So let's write these rules down. Absolute value. If the absolute value, when it's isolated, that means nothing in front, nothing behind, equals a positive value, we get 2 solutions. If the absolute is isolated equals a negative value, we get no solution, 0 with a line through it. If the absolute value equals a 0, we get 1 solution. This is what we just said in words. Do we remember those rules now? We did that, I think, the second week of class, yes? Okay. All right. So, let's go back to number 4. And is the absolute isolated? Is it by itself? No. So we need to move that 7 over. Absolute 3z plus 6. Absolute, if I move the 7 over, it becomes a positive. Now the absolute is isolated. It equals what kind of value? So that means we solve it twice. That's where we get our 2 solutions. So the first time is exactly what we see. So we see exactly 3z plus 6 equals 7. The second one comes from exactly what we see on the left side, but it equals a negative. We're putting that negative in. So before we finish this, you guys just had a test on transformations. What was the shape of an absolute value graph? It was a V. So in a V, in the center of the graph, you have your negatives and you have your positives. That's why we have to put that negative in there. We have to consider both sides of the V when you have an absolute. But when we covered this, we didn't know our graphs yet. But this is how it connects. So when you get to the final, everything's supposed to come together. Okay? All right. We got to solve both of these. Move the 6 over. 3z equals 1. So z equals 1/3. Move the 6 over. 3z equals negative 13. Am I off my screen? Z equals negative 13/3. Can I have a negative for a solution? Can I have a negative answer? We have integers, right? We have real numbers. Yeah. So we get our two solutions. I like my students to write small to big, so they write their negative answer first, or their smallest, and then their next answer. So these are my two solutions for Z as in zebra. All right. So let me pause there. Turn it over. So yeah, we can pause.